Hi everyone, this is Bozena Hufwalne, a building teacher from Outen, and I'm going to be talking about construction materials, your unit of competency 4006. This unit specifies the outcomes required to supervise the systems through which materials are typically selected, acquired and stored on site for projects described by the National Construction Code, known as Building Code of Australia (BCA), for low-rise buildings or construction work. Students always ask questions where they can find information required. I'm sure you have already been using OLS and you know how to use it, but just a quick recap. To find the resources, you select the unit, in this case Cpccbc4006 edition 3, and you can use either online version or download a zip file to your computer. Remember to access your resources frequently, as information there may change. If you click the online version, you would see view like that. You have also building project listed you would be using to complete your assessments. Let's click on topic 1. On this page we can see resources listed for topic 1, and you can download learning material printed in PDF format. Now let's talk about building materials. We are surrounded by them, we see them everywhere, we live with them in our houses or apartments, we walk on them, and last but not least, we admire or hate them. Resources in this unit tell you about the characteristics and quality standards of building materials commonly used in residential scale buildings, and that knowledge will help you to select the most appropriate materials for your work. You will learn about a wide range of building materials, timber and timber products, concrete and concrete products, clay and stone, mortars, plaster and plasterboard, metals and glass, paint and coatings, plastics and adhesive, and so on. What you will need to know is what affects the performance of building materials in general. A well-designed, economical building takes the following factors into account: the properties and behavior of building materials, the initial and long-term costs, the effects on the environment, a very important one, and how the materials interact with each other. We all love trees. Many of us love timber for houses and furniture, so goodbye trees. Where do our responsibilities begin and end when it comes to conserving forests? Too many uses that timber has means that it is seen as a resource which can be exploited for economic benefits. This exploitation has a long history, and some forests, particularly in Northern Hemisphere, have largely disappeared over the past 1,000 years. Now, the same process is taking place in tropical and subtropical forests for similar reasons, but at a faster pace. Socio-economic changes and advances in technology have placed continual pressure on the survival of the forests. However, these economic advantages are often short-term, and the consequences of clearing the forest are long-term and potentially disastrous. The concern of conservationists is not based on sentiment, but on real practical issues. Trees play a fundamental role in the ecology of our planet, oxygenating the air, preventing land and soil erosion, providing nutrients for the soil and habitat for a wide range of animal and plant life. Clearing the land, as we have done in Australia, for short-term agricultural gain, has destroyed the natural balance that existed between these elements and has created problems such as topsoil erosion, land erosion, salt-polluted rivers, the extinction of native species of plants and wildlife. Long-term climatic change is another effect of worldwide clearing of rainforests, and the delicate ecological balance, once destroyed, can never be restored. We cannot go back, therefore, because the effects of clearing forests evolve only over time and are difficult to measure against short-term economic demands. Our most pressing dilemma now is to find ways of reconciling the conflicting needs we have for timber and for preservation of forests. The concept of concrete, probably the world's most abundant building material, is not a new one. It dates back to Roman times and their use of limestone mortar, which was produced by heating limestone and grinding the stone into a powder, which, when mixed with water, formed the paste and set both hard and quickly. It was during this era that the first concrete was produced, when the Romans added sand, crushed stone, or brick or broken tiles to the limestone mortar. Concrete is a composite material which consists of a binder, cement and water. Remember, cement is a powder, commonly referred to as the paste and aggregate. The paste will also usually contain some entrapped air. Aggregates are generally classified into two groups: fine aggregates, which consist of sand with particle sizes less than 5 mm, and coarse aggregates, generally crushed rock of varying sizes but greater than 5 mm. Concrete is tested on the site or in the laboratory to determine its strength and durability, or to control its quality during construction. These tests help the engineer or a job supervisor to determine whether the concrete is as specified and if they are ready to proceed with the job or whether adjustments should be made to the mix. Stone and clay are among the oldest of building materials. The use of stone in particular dates back to prehistoric times, and many ancient civilizations have appreciated the properties of stone and developed the art of using it. Lack of timber or other materials sometimes forced the use of stone, and in other cases, stone was the preferred material because of certain superior properties, such as durability or prestige. The natural enduring appearance of stone and its abundance have ensured its continued use as a building material to modern times. The terms wall lining and ceiling lining refer to the internal wall and ceiling covering of the building as opposed to cladding, which refers to the external wall covering or sometimes roof covering. Additionally, ceiling lining are defined as being distinct from finishes, such as ceramic tiles, wallpapers and paints, which are usually applied to the wall or ceiling lining. The most common forms of wall lining used in Australia are gypsum plasterboard, fibrous cement, timber or composite lining boards or sheets, plastic-coated wall sheeting, and solid plaster. You can see current products on the slide. Metals have been used by humans for over 6,000 years. The first metals were simply picked up off the ground, but in time people learned to extract metals from their ores. Nowadays, the technology has become quite complex, and not only can many metals be extracted from their ores, but the properties of metals can be modified by various types of finishing processes or by mixing with other metals to form alloys. For building purposes, most metals are alloys. The major base metals used are iron, copper, lead, zinc, and aluminium. Metals using iron as their base are called ferrous metals, while the others are called non-ferrous. For example, brass is an important non-ferrous metal used in building, being an alloy of the base metal copper. Ferrous metals are those metals that contain a large amount of iron. They have magnetic properties. The main types of ferrous metal are cast iron, wrought iron, steels. Generally, most non-ferrous metals are more costly to produce than ferrous metals. However, they often have much better working properties and resistance to corrosion. The more common non-ferrous metals are copper, aluminium, zinc, lead, nickel, tin, and cadmium. Glass today is manufactured from the same materials as it was several thousand years ago. Egypt is credited with the earliest glass-making technology at least as early as 4000 BC. In Australia, commercial glass-making began in 18th century in Melbourne with bottle manufacture. Glass is manufactured commercially from sand, which is silica, soda, and lime. Its characteristics are dependent on the proportions and treatment. Now let's have a look to Assessments tab. There are 5 online quizzes assessments. When you have worked through the learning resources and are satisfied with the overall knowledge of the unit, you may attempt each online quiz. Each quiz contains short answer questions and multiple choice questions on selecting, procuring, and storing construction materials. In order to answer some questions, you would have to familiarize yourself with 3 building projects. Some questions would refer to the 3 projects. Please remember, the projects are located at the introduction of each unit. Good luck! There are new materials and new technologies introduced to buildings material sector as well. Imagine, I have told you there is a technology that allowed windows to clean themselves. It's not a science fiction. Actually, it's a science fact, and this technology was available commercially for over a decade. Let us learn about it. Let us watch how it works.
Everyone knows the value of a superior crystal clear glass, but who hasn't experienced the effect of glass becoming more and more opaque and harder to clean over time? Why does this happen? Close examination reveals that glass is not as smooth as it appears. The surface of glass actually has complex topographic features. These peaks and pits in unprotected glass attract deposits such as dust, dirt and grime. These get lodged inside the glass surface, together with calcium deposits, inorganic dirt and water corrosion, and attack the glass. This gets worse as time goes on, slowly causing the glass surface to deteriorate. Can this be prevented? Yes, it can, and quite easily. Inspired by the natural water repellency of the lotus leaves, by replicating their nanoscopic surface architecture, a brilliant self-cleaning coating has been developed. Available now, the Balco Nano Surface Protection is the ultimate solution. Balco Nano forms a hard, smooth and water-repellent surface on the glass. Dust, grime and other deposits cannot lodge and cling strongly to the surface of the glass, and they wash away easily. With Balco Nano applied, water does not form a film on the glass. The Balco Nano coating makes water droplets curl up and roll away easily. All types of glass, and is also great for porcelain, ceramics and marble. It's very easy to apply. Designed so that it can be used by the private homeowner and industry professional alike. Similar to the way Teflon works on a frying pan, Balco Nano will make glass cleaning use on doors, windows, showers, bathroom tiles, glass balconies and many other applications. Balco Nano is eco-friendly.
In my view, the subject of building materials is a very interesting one, and I sincerely hope you would enjoy it the same way as I do.